Hey everybody, welcome to the statistics review video number 1. Now, the goal in these videos is to review some basic ideas from statistics, and particularly as it relates to data, because this statistics review will really help you with data analytics and data analytics related courses in the program. Okay, so in this video, I'm just going to give you an introduction to data. What are you looking at when you look at a data set? All right, so let's jump in. Okay, so when you look at a data set is always going to be organized as a table. It's going to have columns and it's going to have rows. And so what you see here on the slide is exactly that. It's a very simple, small table. It has 3 columns and it has 4 rows. Okay, and so this is a data set for us. All right, and when we look at a data set has very specific kinds of information contained within the columns and within the rows. All right, in a data set, the columns refer to variables, this thing called a variable. So a variable is a mathematical object that can take on different values. It varies. It is able to vary. So it's a variable, able to vary, right? Okay, so the columns of a data set are variables. And the rows of a data set are called observations. Okay. So an observation in a data set is some unit, something that we are observing values of the variables for. All right. In a lot of cases, an observation is referring to a person. Like we will collect data on people, and each person will have a row in the data set. So we could think about this as person number 1, person number 2. And then each column of the data set has information about that person. All right, let's walk through this step by step. So the first column here in this data set, and this is somewhat common with data sets, is that there will be a column in the data set that simply labels or gives a label to the observations. And that's what you see here. This lowercase letter I, it just means that this is a variable that is going to vary by the observation, and we just use the letter I to kind of label that. Okay, and so here I'm just assuming that this is a data set that was collected on people, so individual people. So each row corresponds to a person. And therefore, this is person 1, this is person 2, this is person 3, etc. All right. Now, moving beyond, the rest of the columns, again, these are our variables. All right, so here we have variable y and variable x, just named generically. We could make up examples, and I think I will in a moment. But we have 2 variables in this data set, and these variables take on different values for the different people in the data set. So for example, for person 1, the value of the variable y is y1. And for person 2, the value of variable y is y2. And likewise for x. To make that more concrete, let me just kind of give an example. Imagine that the variable y was age, and imagine the variable x was education. Perfectly reasonable variables. We might want to collect a data set in which we measure people's age and their years of education. All right, so that could totally be it. So what we're looking at here is that the variable age is a variable that takes on different values for each person. So let's imagine that person 1 is 40 years old, and person 2 is 55 years old, and person 3 is 19 years old. Well, these are different specific values of the variable age that correspond to each observation in the data set. Likewise for education. Perhaps person 1 is 40 years old and has 16 years of education. Perhaps person 2 is 55 years old and has 12 years of education. Perhaps person 3, again, 19 years old, and maybe they have 13 years of education. All right, what you'd be looking at there is a data set. Okay, now, again, in data sets, we have variables. That's what the columns are. And those variables can have different types, or I should say, we can have different types of variables. We can have different types of data contained in our variables. And so one really important skill when you are working with data, when you're looking at data, is to understand what kind of data you have. The kind of data that you have will have a big influence on what you can do with that data. What kind of graphs can you make? What kind of analysis can you do? Well, that's going to be influenced by what kind of data you have. Okay, so let's take a few minutes here and kind of discuss the different types of data we can find in a data set. All right, now there's quite a few different types of data set, different types of data that you can find in a data set, but I'm going to kind of break it down into a couple of categories here. All right, so two big categories of data that we can have are one, categorical data, and two, quantitative data. In fact, I should probably number it differently. I'm going to talk about quantitative data first in this lecture. So we can have quantitative data and we can have categorical data. Quantitative data is data that comes in the form of numbers. It's quantitative, and those numbers have a quantitative meaning. They have a measurement meaning to it. So we can think about this. In fact, in the recent example, when we said this was age and this was education, in both cases, they were measurements of something in real life, the number of years of age, the number of years of education. Those were examples of quantitative data. Categorical data is data that it can take on numeric values, or it can take on words or symbols. It can take on lots of different content, but where the value just labels the observation into categories, and that's why we call it categorical data. Okay, now within quantitative data, we have continuous and discrete, and I'll explain that difference in a minute. Within categorical data, we have nominal and ordinal, and I'll explain those in a minute as well. So let's jump in first to quantitative data. All right, so like I said, quantitative data is data that consists of numbers that represent counts or measurements. All right, and we have continuous and discrete quantitative data. All right, so continuous, a continuous variable, we could say, a variable that contains continuous quantitative data, or a continuous variable, is data that can take on an infinite number of possible values within a given range. All right, it can take any value within a range. All right, continuous variables often come up when we're measuring quantities in real life. Okay, so we could say the speed of a car is a continuous variable because you could measure speed down to an infinite number of decimal places, for example. All right, so continuous variables or continuous data is data that can take on any value within a given range. Discrete quantitative data, or a discrete variable, right? Discrete quantitative data is also quantitative, it's numeric, and it constitutes measurements, but it can only take on particular values or a finite number of possible values within a range. So when we measured education in years a moment ago, that was an example of a discrete quantitative variable or discrete quantitative data because we only allowed it to be measured in years. And people are probably not going to have, maybe more than 20 years of education. And so you only have values from maybe 0 to 20. And that's about it, right? And it's discrete. It can't take on any value between 0 and 20. It can only take on whole numbers between 0 and 20. So that was an example of a discrete variable or discrete data. Okay, now technically speaking, these are our options in terms of quantitative data. But oftentimes in practice, we make a special case for something called a binary variable. We actually use binary variables quite a bit in data analytics. A binary variable is a variable that takes on the value of 1 or 0. It's also sometimes called a dummy variable. Now, technically speaking, even though the values of this variable are numbers, it's not really quantitative data. It doesn't constitute a measurement. In fact, binary variables are actually, more appropriately, we should say, a binary variable is actually categorical. But binary variables are this special case, and it's a special case because we can use it in similar quantitative, meaningfully quantitative ways. Okay, we'll see that. You'll see that when we do data analytics. I'm just explaining why I'm listing it here, even though it doesn't perfectly match the definition I gave a moment ago. All right. Okay, so just to maybe be clear with these definitions, we have discrete versus continuous. So a practical example that we might see for a continuous variable would be, let's see, what is your family's annual income? Okay, that is measured in dollars. It can be measured down to an arbitrary number of decimal points, and so it's a continuous variable or continuous data. Discrete, I kind of mentioned this example a moment ago. If we measured someone's education in years, that would be discrete. It can only take on specific particular values within a range. All right, and then lastly, which again, admittedly, this isn't really a quantitative variable, but we use it like it is, a binary variable. We could ask, are you a veteran? And it's just simply yes, which is given the value of 1, or no, which is given a value of 0. Okay, that's quantitative data. Now, what about categorical data? Categorical data is data that where the entries, the values of the variable are words, symbols, names, or numbers. But no matter what the contents are, what the value is, what the value does is it labels the observations into a category. It labels observations into a category. I mentioned a moment ago that binary variables are really categorical variables. And so this would be a good example of a simple categorical variable. Are you a veteran? Yes is 1, no is 0. So this number 1, all it does is it labels that person as a veteran. And the number 0, all it does is label that person as a non-veteran. All right, so that would be an example of a categorical variable. We'll see more in a moment. Okay. Now, categorical data can come in two forms, or at least one way to think about it is two forms, nominal and ordinal. Now, a nominal categorical variable is a categorical variable, or I should say again, categorical data. Nominal categorical data is data where the labels cannot be arranged in an order where the order communicates information to us. I'm going to give you an example in a minute. But a nominal categorical variable or nominal categorical data, the values cannot be put into an order where that order tells us something about the data. Any ordering would just be arbitrary. All right, that would be a nominal categorical variable or nominal categorical data. Okay, that's by contrast to an ordinal categorical variable or ordinal categorical data. Okay, ordinal categorical data can be arranged in an order where the order is meaningful. It tells us something about that variable. Even though the gaps or the differences between values are meaningless, they don't have any particular meaning, the order itself tells us something. All right, now to make that clear, let me just give an example. So here's an example of a nominal categorical variable. Let's say we could ask a farmer, what crop did you grow last season? And maybe they could give us different answers. Maybe they grew corn, rice, beans, potatoes. These are, let's say, the different categories. We can use these are the categories, and we can use these to label the farmer according to what crop they grew last season. All right, so these are the different categories. But you can see that I could order these in any order. It doesn't matter. In this case, I listed corn and then rice and then beans and potatoes, but that ordering doesn't mean anything. I could just as well have done rice and then beans and then corn and then potatoes, and that would have that would have made no difference whatsoever. It doesn't matter what order I put the values in. The order doesn't tell us anything. Any ordering of these categories is just arbitrary. Okay, but if I ask the question, what is the highest level of education that you've completed? Maybe someone has completed primary school, someone secondary school, some all the way to university. These are categories that we can use these categories, these labels, to place a person into a category in terms of the highest level of schooling they've obtained. But these categories can be put into an order where the order tells us something. You can see in this case, the order goes from less schooling to more schooling. So the order tells us something. If I listed these values as secondary school, then primary school, then university, you could tell me, you could say, oh, that's incorrectly ordered. That is not ordered correctly because primary means less schooling than secondary school. Right? So someone who's completed secondary school has more schooling than primary. So these are not ordered correctly. They aren't in an order that makes sense. They're not in an order that communicates information. We need to switch these around. All right. So an ordinal categorical variable has a coherent ordering of the categories. Okay. Now, another distinction that we might make when we are looking at categorical variables is we might make a distinction between a numeric categorical variable and a non-numeric categorical variable. A numeric categorical variable uses numbers as the category labels. The numbers don't have any meaning in themselves, but it just uses numbers to as the label for the category. All right. A non-numeric categorical variable just uses words or symbols. It just uses not something other than numbers to label the categories. Okay. Numeric and non-numeric categorical variables are oftentimes interchangeable. So here's an example. Imagine I have a variable and it's called marital status, and we're using this marital status variable to label observations according to their marital status. And there's different marital statuses that one could have. Someone could be married, someone could be single, someone could be widowed or a widower, right? And et cetera, men, others. So a numeric version of such a variable could be this, where you could say marital status equals 1 if a person is married, and marital status equals 2 if they're single, and marital status equals 3 if they're widowed or widower, if they're a widow or a widower. Okay, these numbers don't mean anything. The numbers themselves don't communicate anything. We're just using numbers as the label. All right, and likewise, I could have a non-numeric categorical variable, the same thing, marital status, where I simply use words as the label instead of numbers. You can see in this case, these are just interchangeable. Okay, so you'll want to be careful when you're looking at a data set and you're looking at the variables in that data set. If you see that a data set has values that are numeric, that does not necessarily mean it's a quantitative variable. It could be a categorical variable that's using numbers as labels. Okay. All right, here's another example of a numeric categorical variable. This is an example of a numeric ordinal categorical variable. All right, so here, this example that I just went through, this would be a numeric nominal categorical variable where the ordering does not matter. Here's a numeric ordinal categorical variable where the ordering does matter. Okay, so this is a numeric nominal categorical variable, numeric nominal, where the order doesn't matter. Here's a numeric ordinal variable where the order does matter. Okay, so something that you'll see in data sets and surveys from time to time is a question that is measured on what's called a Likert scale. So this would be something like, how much do you like this class so far? And we measured on a scale from 1, not at all, up to 5, you like it a lot. All right. So here we're using numbers to label people according to how much they like something. Where the ordering matters. Okay, so it's numeric because we're using numbers, right? We're using numbers. And it's ordinal because those numbers can be put into an order where the order matters. The order communicates information to us. We know that 5 is a greater amount of class satisfaction than 3. So the order matters. So it's numeric and ordinal. This is a common kind of data that you might run into. Okay, so what I want to do now is I want to transition over into R, and I just want to look at a data set with you. All right, so let's do that. Okay, so here we are. Now I am in the R Studio environment, and I am going to kind of just walk you through a little bit of looking at data in R. Okay, so again, so here we have kind of our script area. This is where we'll do our coding. Here, down here, we have um, where our results will come out. Up here is where we'll see our data sets. And down here, this is where we find the packages that we are using and plots we will produce and access to files on our computer. Okay, so these are the kind of the different windows that we can see when we're using R. Okay, now when we use R, we oftentimes need to use what we call packages. And packages are collections of functions or operations that we use in the software. There's a lot of great packages in R, and so oftentimes, if you haven't used a particular package at all or ever, you'll need to install them. And then even if you've installed them, when you want to use one on your particular in a particular session, you'll need to inform R that you want to use it by using the library command. Okay, so here I have some packages, um, kind of basic packages from the tutorial. Here are packages that I will be using soon. All right, so in this lecture or this video and in subsequent ones. So I'll just go ahead and run and install these packages. Now I have already installed most of these. All right. So I don't actually need to install them, but I'm just going to do this um, for your sake. All right. Sometimes when you install packages, you have to allow R to restart. So I'm doing that right now. All right. So I've installed the packages. Now I'm just going to tell R what libraries I want to use. That is, tell R what packages I want to use during this session. I'm just going to use these. So run these. All right. And then, so this is where it gets fun. I want to import a data set. All right. Now, the data set that I want to import is called wages, and it's a CSV file. So I'm going to use this command, read.csv. And I'm going to create a data set in R, and I'm going to call that data set wages. I'm just going to give it that name. All right. That happens to also be the name of the data set on my computer. All right. So what we do here when we want to create a data set in R is we will tell R, hey, I want to create something called wages, and I want it to be equal to, all right, this is kind of the equal sign in R. Okay. And then we're going to give it the command read.csv. So it's going to it's going to bring in a CSV file. All right. Here, maybe I can even type this out as I talk. So I want to create a data set in my R software called wages. All right. I want it to be equal to a data set that already exists on my computer. And the data set on my computer is a CSV file, so I'm going to use read.csv. That's a function that brings a file on my computer that's a CSV file into R. And then inside the parentheses, all I need to do is give the file path on my computer to where that data set is located. All right. Now I happen to already have that. And so you can see it here. This is the file path on my computer. All right. You would just have to look up the file path on your computer and place it inside of those parentheses in quotation marks, either single or double quotation marks. Once you've done that, then you can hit that line, you can highlight the line and hit run. And what it will do is it will import that data set into your computer. You can see now I have that data set on my computer. And again, it's given the name wages because that's the name I gave it. All right, so there it is. We now have the data set called wages. If you just click on it, we can look at it. Okay, so here is a data set. It's got 1, 2, 3, 4, 5, 6 variables. You can scroll down, you can look at the data. All right, you can kind of peruse it. We can even look at it. We can kind of say, what kind of data is this? It's like, well, okay, wage, this is a variable. And actually, you can even see as I scroll my cursor over top it, it says numeric with range 0 to 26. So it actually tells us what the range is. You can see it's measured down to at least one decimal place. I would look at this and I would probably just go ahead and call this a continuous quantitative variable that's measuring people's wages. All right, EDU, that probably means education. All right, you can see it's not measured down to a decimal. It probably only takes a very small number of discrete values. Let's call that a discrete quantitative variable. It's probably measuring years of education. Experience, that's what EXP means. That's experience. Similar thing. All right, the number of years of experience. There's a lot more years here. Sometimes the distinction between continuous and discrete quantitative variables can become a bit imprecise, like how you want to think about it. I'm not too worried on these kind of edge cases. You could think about this as continuous. You could think about it as discrete. It's not a huge deal either way. Here we have a variable, veteran. So this looks like it's a binary variable or a dummy variable. It equals 1 if they're a veteran and 0 otherwise. So this, technically speaking, is a categorical variable, a numeric categorical variable, but oftentimes we can treat these kind of quantitatively as well. So then we have marital status. So that's a categorical variable, a non-numeric nominal categorical variable. And then here we have female. So, okay, this is another binary variable, equals 1 if they're female and 0 otherwise. So this variable, again, binary dummy variable. All right, so it's a binary variable or a dummy variable. Okay, so that's our data set. When we're looking at data set in R, we can do a few things. We can report some information about the data set. So what I just ran, str with the name of the data set inside of parentheses. This just tells us a little bit about the variables in the data set. So here we can see, here are the different variables. All right, it tells us what kind of variable it is. You can see that in R, it uses some different names for the variable types. I'll just clarify that here. So num, that's going to correspond to a continuous quantitative variable. All right. Int, that's referring to integer, so that's typically going to be a discrete quantitative variable, but it takes on integers. All right, integers, so which is going to be discrete. All right, so you can see that that veteran and female, we know those as binary variables or dummy variables. You can see that R treats those as integers as well because it takes on integers of 0 and 1. And then you'll see CHR, character. So what R is saying, okay, this is a non-numeric categorical variable, and it contains um, writing, so not numbers. Okay, so that's a character variable. So sometimes we'll say character variable. Sometimes you'll also see that written as a string variable. Sometimes you'll hear that referred to as a string variable. Okay, you also can do, you can run the head command. The head command will just show you the first couple of rows of your data set. Sometimes that can be helpful. And you can run the summary command. And summary is going to give you a bunch of information about each of the variables, the min, the first quartile, median, mean, third quartile, and max of each variable in your data set. Sometimes that can be helpful. We'll talk more about descriptive statistics in the next lecture. All right, everyone, that's it for now. Hope you have a great day. Bye.